Hello, my name is Stephen Galemi, Technology Manager, Control Room Operations. I'm joined today by two very experienced TSCs, Peter Braun and Jim Rathburn. Peter has over 20 years experience in the batch industry and with safety system. Jim has over 20 years experience in the power industry doing design and plant startups. What I'm going to talk to you today about is the Foxboro Evo automation system and how the Foxboro Evo automation system helps solve the challenges to engineer. The challenges specifically we're going to talk about today are as follows. The need to troubleshoot problems quickly, the need to lower cost and decrease footprint of the system, and the need to be able to effectively manage constant change in the plant. To describe these challenges and how we're going to solve these challenges, we're going to use a little scenario which requires that the two engineers in the plant have just finished implementing a large design change notice, and now they're finishing up the work to complete that effort. The design change notice will include over 3,000 discrete I/Os, over 1,500 analog I/Os, and a small amount of I/O in the field associated with a skid-mounted unit. The features we're going to use to help the engineers solve these challenges are the Foxboro Evo control editors, the dynamic appearance objects based on SAMA, the FCP280 and the brand new Compact200Series I/O, and the intelligent marshalling with universal I/O. With that, I'll turn it over to my two TSCs to go through the role play.
Thanks, Steve. Historically, when it comes to large-scale competitive bids, the Foxboro company has been at a disadvantage. The footprint of our I/O was just too big and too clumsy. It takes us 800, we can put 800 points into a cabinet where our competitors can put over 1,600. The solution to this problem is the new Foxboro Evo 200 Series I/O in the compact version. These new slim design allow us to put 16 I/O cards in the same space that it used to take 8 I/O cards, thus doubling our I/O capacity. We now are able to put 1,536 analog points into one cabinet or 3,072 discrete points into one cabinet. This now brings us to the higher end of the spectrum of I/O capacity.
Okay, thank you, Jim. The next challenge we're going to talk about is the need to be able to effectively manage constant change. In this scenario, we're going to talk about two aspects. We're going to use the universal I/O to help us address that, and we're going to talk a little bit about automation of the safety integration files into the automation system. With that, I turn it back over to my two TSCs.
Peter, I got some bad news for you. It seems that the universal I/O that we configured last week out in the skid is wrong. We have a bunch of points that are now externally powered. They need to be internally powered. We're going to be down for a couple of days to fix that. I have to go get a work order, and I have to send someone to a hazardous location to do the rewire.
That's not a problem, Jim. The universal FBM is software configurable, and everything we need to do, we can do from the engineering station.
Everything, but this is a wiring change. We need to send someone out there to rewire these points. It's not a software change.
No, it is a software change. The universal I/O configures everything from the engineering station, including whether inputs and outputs are powered from the DCS or the field. Let me show you how. From our engineering tool, we have a pull down for the configuration of the universal FBM that allows us to select from a simple pull down whether the inputs, in this case analog inputs, are externally powered or loop powered. So I can just select loop powered for the two inputs that are faulty, and it's fixed.
Wow, that was easy. And it saved me all the aggravation of dealing with management, and I didn't have to put anybody at risk. Foxboro Evo is truly amazing.
Okay, thank you very much, Jim. Now we're going to talk a little bit about how we can automate the integration from the safety system into the process automation system.
Peter, another challenge has come up. We just changed 50 points in our safety system, and they've yet to be integrated into the DCS. Can you show me how that was done in Foxboro Evo?
Yes, that's very straightforward, Jim. We can take the configuration file from the Tricon system and load it into our configuration tool, Foxboro Evo. And we simply select the points that we want to bring into our DCS. We then generate a simple file, and after saving it, generates a file that we can then generate using the bulk data object. That will then automatically create the objects we need in the DCS to interface with the Triconic system. So I've just created that file. If I go in the bulk data object, I can select the Tricon node that I want to interface and the CP that the data will come into. Say OK to generating the new points. And then it's a simple matter of clicking generate. And now all of the blocks that are required to talk to the Tricon are automatically configured in the DCS.
And all the blocks that you need to add and delete were done automatically?
Yes.
And you didn't have to type in any information?
No, I only had to enter the data once in the safety system and it's automatically configured in the DCS.
And that completely eliminates human error?
Yes.
Wow, Foxboro Evo is truly amazing.
Great. That was, thank you guys. What we just heard was how the universal FBM and safety integration help solve the challenge to effectively manage constant change. The universal FBM allowed us to stay in the control room and implement changes all from the control room, eliminating the need to send personnel into potentially a high-risk environment out in the field in a hazardous location. Additionally, the automation of the safety integration allowed us to automatically take the configuration file from the safety system and automatically create the Foxboro Evo control interface database. It's very, very thank you. The next challenge we're going to talk to you about today is the need to be able to troubleshoot problems quickly. Today we're going to do that under the scenario using the SAMA dynamic appearance objects, and I'm not sure if you've heard about SAMA or not, but you're going to find out about it right now. With that, I'll turn it back over to Jim and Peter.
Peter, just got off the phone with operations. We have another issue. Our airflow signal seems to be off, and we need to troubleshoot that loop. Do you have an easy way to do that with Foxboro Evo?
Yes, that's no problem, Jim. We can use our dynamic appearance objects, SAMA diagram, where we can see from the strategy a graphical representation of our function block configuration.
Wow, that's cool. I see the problem already. This is supposed to be an average, not a high select. Can we change that here, or do I have to go somewhere else?
That's very easy. I just double-click the SAMA object to open its configuration screen, and I can change the mode in this case to do an average of the two inputs, and then save it.
Wow, that documented your change as well. I don't even have to go through drafting, and I don't have to worry about another engineer coming along later and not knowing the changes I made. That's truly self-documenting. Truly amazing. We have another problem we have to deal with too. We have a motor that's not starting. Can we do this in Boolean as well?
Yes, we can also see the Boolean logic from the same strategy diagram. Use the motor logic, and we can see all the inputs to the gate that controls the starting of the motor.
Well, that's all fine and well, but it's just showing me a logic wrong. I don't know which points are true. How can I troubleshoot this?
We can very easily switch it into live mode to see the status of all the points on the logic diagram.
Wow, that's cool. I can see all of my inputs. I see that my permit isn't engaged. That lube oil pump is busted. We do have another lube oil pump to back it up, but it isn't wired yet. I need to go run down and get my nest load, and we'll wire it up, and we'll be right back in business.
There's no need to go and get your nest loads. We can see the I/O allocations directly from the configuration tool. If I call up the controller, I can see all of the function block FBMs connected to that controller, and also the I/O allocation of each FBM. I can see here I have a free FBM that has no I/O allocated, so we can use that. And because it's a universal FBM, we can configure each of the channels to suit the I/O requirements for the new pump.
You mean the same I/O card is going to do analog ins, analog outs, digital ins, and digital outs?
That's correct.
That'll reduce my footprint even further. I have one FBM where it took 4 before. Foxboro Evo. Truly amazing.
All right, very good. Thank you, gentlemen. So what we just heard was how the dynamic appearance objects based on SAMA provide a very intuitive view of the control strategy, making it very obvious to see what's going on inside the control loop. Additionally, when the configuration of that control loop was changed, the drawing automatically update, making the documentation as built all the time and eliminating, as Jim talked about, the need to go to drafting and redline and check all that, completely eliminating the human error. In addition to that, by using the live live data display to troubleshoot the Boolean logic, we were very quickly able to determine that the inputs, the startup permissions was not satisfied, and that needed to be addressed before the motor could start. However, the motor was, the pump was down, so we had to rewire in a new motor. And by using the Foxboro Evo I/O referencing, we could easily determine where a spare point was located on the system. Very, very good, very exciting. Thank you very much, gentlemen.